Mirror matter is a hypothetical form of matter proposed to restore a fundamental symmetry in physics known as parity symmetry. In ordinary experience, a mirror reflection reverses left and right but preserves physical laws. However, in the mid-20th century, physicists discovered that certain subatomic processes violate this symmetry. The weak nuclear force, responsible for processes such as beta decay, behaves differently in left-handed and right-handed coordinate systems. This discovery overturned the long-standing assumption that nature treats mirror images identically. To restore symmetry at a deeper level, some theorists propose that every known particle might have a mirror counterpart, forming an invisible parallel sector of matter. Parity symmetry implies that physical laws should remain unchanged if spatial coordinates are inverted, like viewing the universe in a mirror. For decades, this was assumed to be true. In 1956, theoretical work by Sung-Dao Lee and Chen-Ning Yang suggested that parity might not be conserved in weak interactions. Experiments soon confirmed this prediction. The violation of parity was profound because it revealed that the universe distinguishes between left and right at a fundamental level. Mirror matter theory proposes a bold solution. Instead of abandoning symmetry entirely, it suggests that symmetry is preserved globally if a parallel mirror sector exists. In this framework, every ordinary particle, such as electrons, quarks, and neutrinos, has a corresponding mirror particle with identical mass but opposite-handedness in weak interactions. Ordinary particles interact through familiar forces, while mirror particles interact through mirror versions of those forces. The two sectors would be largely decoupled, communicating primarily through gravity. If mirror matter exists, it would be invisible to ordinary light. Mirror atoms would form mirror stars, mirror galaxies, and possibly mirror planets, but their electromagnetic radiation would not interact with ordinary matter. From our perspective, mirror matter would appear dark. This feature has led some researchers to explore mirror matter as a candidate for dark matter, the unseen mass that constitutes roughly 27% of the universe. Dark matter is inferred from gravitational effects on galaxies and clusters. Observations of galaxy rotation curves show that stars orbit faster than expected based on visible matter alone. Additional unseen mass must provide the necessary gravitational pull. Mirror matter could supply this missing mass if it exists in sufficient abundance. Because it interacts gravitationally but not electromagnetically with ordinary matter, it would match many properties attributed to dark matter. However, mirror matter models must satisfy stringent observational constraints. The cosmic microwave background and large-scale structure measurements tightly constrain the amount and behavior of dark matter. Any viable mirror matter theory must reproduce these observations without conflicting with nucleosynthesis predictions or galaxy formation models. Some versions propose slight interactions between ordinary and mirror photons or neutrinos, allowing limited coupling between sectors. These interactions must be weak enough to avoid detection in laboratory experiments. One intriguing implication of mirror matter is the possibility of mirror stars or compact mirror objects passing through our galaxy. Because mirror matter would interact only weakly with ordinary matter, such objects could traverse space undetected except through gravitational influence. Searches for anomalous gravitational microlensing events have been considered as potential tests, though no definitive evidence has emerged. Mirror matter also has connections to neutrino physics. Neutrinos already exhibit unusual behavior, oscillating between different flavors. Some theories suggest that neutrinos might oscillate into mirror neutrinos, which would not interact with ordinary detectors. Experiments continue to test for anomalies in neutrino behavior that could hint at hidden sectors. The idea of mirror matter extends beyond restoring parity symmetry. It reflects a broader principle in theoretical physics. Symmetry often guides the search for deeper laws. When symmetry appears broken, theorists sometimes hypothesize hidden structures that preserve it in a larger framework. Mirror matter represents one such attempt to reconcile symmetry with observed violations. Despite its elegance, mirror matter remains speculative. No direct experimental detection has confirmed its existence. Particle accelerators have not observed mirror counterparts, and astrophysical observations have not uniquely identified mirror structures. Nonetheless, the concept remains an active area of theoretical research, especially in discussions of hidden sectors and extensions of the standard model of particle physics. In conclusion, mirror matter is a hypothetical parallel form of matter proposed to restore parity symmetry in fundamental physics. Consisting of mirror counterparts to ordinary particles, it would interact primarily through gravity and could potentially explain dark matter. While consistent with certain theoretical principles, it faces significant observational constraints and lacks direct evidence. whether mirror matter represents a real component of the universe or an elegant but unverified idea. It illustrates how symmetry considerations drive exploration at the frontiers of cosmology and particle physics. If you like the video, share it and don't forget to subscribe. Cosmic Secrets 108, turn on notifications. See you in the next video.